This is the dark Doodad Nebula imaged from the Kagakama Remote Observatory in South Africa, and today you and I are going to process this image in Siril. I'll provide the data for free to anyone who would like to follow along. The free link will be on Buy Me a Coffee. It has a couple extra steps, and if you are on Patreon, you will see the associated post with the attachment that you can download and follow along. Of course, you can use your own data to follow along if you'd like, because these steps are reproducible with pretty much any dark nebula. And this target here is kind of interesting because it has this globular cluster, NGC 4372, and it's mixed with all the dust in the dark Doodad Nebula, and it's been really hard to process. And on my website, I have something that I'm kind of happy with, but I'm hoping that sharing this data with you, maybe you can come up with a better process than I'm going to show you. And in this video, my goal is to show you the simplest path to getting something that looks kind of nice. And when we compare it to what the raw data looks like, it's kind of incredible what we can do with such a short amount of processing time. We'll be using Deep Space Astro's workflow companion, so I'll include the workflow JSON file that you can download, import it into Siril, and follow along there as well. If you use this data and you share it online, credit is always appreciated. Also hop on our Discord server, post your version there, and I'll pick some of the best ones and share it in a YouTube post in the near future. Let's get to the tutorial. Right, so we have Siril open, and I have my final fits from the stacking of the dark Doodad Nebula. You can use your own data, but you can also get this from Buy Me a Coffee and on Patreon for free. And we're going to be working with Deep Space Astro's Workflow Companion v1.1.3, where I laid out all the steps I'm going to take. Again, this is going to be as simple as possible. And the first option here is I named it a stacking plate solving SPCC. It's just a group. We're not going to do this one, the Astronomy OSCPP, even though I ran it just to show you that if you're starting with your own data, stack it, and then when you get your final fits file, open it here, and you can continue with the rest of it. So that's just there as a reminder. Next, we need to do is we need to manually crop this. So I'm just going to make a box around here, right click, crop, and crop again. Great. Going back here, so we need to do a plate solve. This is not available through one of the processes here. So we're going to go to Tools, Astrometry, Image Plate Solver. This is actually already plate solved, so it doesn't really matter, but always good to just do it one more time. Plate solve super quickly. And then we're going to do spectrophotometric color calibration. So I'll click on play. And this is, we're going to use average spiral galaxy. We are using an IMX571 sensor and no filter here. So there's no RGB filter, no UV IR cut filter, nothing. It's just a standard OSC color camera. And we're going to click on OK. And this should give us stars, or good color stars. I'm just going to close these white balance summaries. If you also saw the version of this on PixInsight, you'll notice that I also did a flip. So the dark Doodad Nebula looks a little bit different in that video. I didn't do that on purpose here because when Siril opens this, it opens it in the correct orientation, so I don't have to do a mirror. But it is upside down, but which is perfectly fine. It's like we were looking at it, with our telescope rotated. But this is fine. So I'm not going to do a rotate here. So this is done. So I'm going to click check. So we are done with that section. Next, we have a stretch. So normally we would try and do a star removal, but this little cluster here is super annoying because it is surrounded by a lot of gas and dust, and it is impossible to do StarNet on this without really messing with the rest of the nebulosity there, or it looking weird. So what I'm going to tell you here is that you can, if you want, you can flip the star removal and the stretch options with your data. With this data that I'm working on, I'm going to do a little bit of a stretch first, and then I'm going to do a star removal, and then I'll do more stretching later on. But for your own data, do what feels right to you. So you can do generalized hyperbolic stretch, or you can do a Verilux hypermetric stretch. So since the Verilux hypermetric stretch works really well with the stars in it, I'm going to use that. So it launched it in the other thing. I'll do a live preview. The Sony IMX that is selected. Let's see. Okay, and I think this looks fine, just a basic auto calculation. And then I'll click on process. Alrighty then. Close this up. So now I can get rid of histogram and go to linear. So unable to set geometry. Now, this is a weird error here. We can ignore this one. And the next thing we're going to do is, so we're going to now check this off. Now we're going to do a star removal. Again, like I said, you can do star removal first if you want. There's two ways to do it, StarNet or Starless, which is from Cycon. I'll use Cycon here. This is the free version. Let it launch. So this opened up, and we want to make sure, I'm just going to keep everything default, and I just want to make sure that my generate star mask is selected, because I do want that star mask to bring in later. So I'll click on process image. Right, that ended. You can see that Cycon had some issues getting rid of some of the stars in the globular cluster, as well as some of the bigger stars here. And if you notice, you'll also see that this is actually oriented differently. And that's because this is I think this is like a Siril weird quirk where every other software sees it like this, because that's how Siril outputs it. But when Siril displays it, it's like this. It's kind of annoying, honestly. But anyways, this is done, and then we'll click on import to Siril, and there you go. It opened up in Siril. You can see, look at that. It's upside down. See, this is why I have to mirror it when I did this in Photoshop in PixInsight. But anyways, StarNet may have given me better results. Doesn't matter. I'm going to mark this as done. Next, what we're going to do is we're going to play with the color and the contrast. So this is where Verilux Curves is going to come in handy quite a bit. So I'm going to run that. And I want to do range limiting here. Click on Show Mask because I don't want to affect the entire thing. And I'm going to try and let's see if I can hide some of that. All right, setting it to 23 to 51 and then feathering of 22. Okay, let's see. So I'll apply this. And then we're going to do another range mask. So I wish this saved. So clipping the whites a little bit. So this is something to play with. Apply. I'm going to go to my lightness here. So again, I want to make sure I'm not getting all those other stuff. And show mask. It's starting to look pretty nice, although these regions are kind of not looking nice. So I'm hoping once the stars blend in there, it looks a little bit better. So I'll click on process, let it do its thing. All right, here we go. So now the next thing we want to do is we can do contrast limited adaptive histogram equalization as well. See if we can get some of this to pop up a little bit. Look at that. Okay, that's great. Going back here, I might actually go back to the stretch. Oops. I want to come back here and actually, I'm going to uncheck this so that I can do another GHS here just to see what that looks like. So I'm going to switch this to linear. Apply. And then I'm going to go to generalized hyperbolic stretch, and I'm going to stretch this just a little bit. So I'm going to draw a box here, do my symmetry point. Make sure my highlights are protected. Yeah, this glob here is really hard to process, but maybe some of you will have better luck. So click on apply, close. Okay, so far this is okay. I think once I merge the stars back in, it'll start to look a little bit better. Next thing we want to do is, I'm going to mark this checked again. So just a reminder that I had GHS after here. So maybe I should add it again. But for now, I'll just leave it, and I will check this one off as well. All right, next up on the list is to do a noise reduction. So I had both of these as an option here, the SCUNet and then Cosmic Clarity, but this is not running for me right now. So I'm just going to switch to Cosmic Clarity and let that run. That usually works. So we have this, make sure everything is set here, and then do a denoise on the luminance, use GPU, and let's try and see how that runs. Okay, there you go, that ran. If you zoom in and then we go back and forth, Did a pretty nice job with this. Okay, cool. No problem, no problem. So I'll mark this as complete as well. And normally we would just do a quick recomposition, but let's see if we can do some extra work here. We can go to stretches, do some curves, transformation here. Let's see if we can make this look a little bit brighter. Just like a quick S curve. You can see that the nebulosity around this is popping. Okay, click on apply. And I'm going to close it. Now we're going to do a star recomposition. So the two ways to do it is you can use Verilux Star Recomposer or the Star Recomposition tool, which is built in. Oh no, let me save this. Save. You know, forgot to do that last time. So what I'm going to do is I'm going to show panel. Let's see. I'm going to add. So I'm going to add a step here, right? Save your image. Put it right over here after noise because, oops, not in there, in down here. Come on. There we go. Save your image because we need to save it. Great. Okay. Then hide panel. Great. Okay. Now we saved it so that we know what it's happening. It is the starless OG fits. And the next thing we're going to do is star recomposition. It'll ask, do you want to close? Yeah. And then we're going to open our starless image and then our star mask. It actually looks pretty good already. And the reason we don't have to do anything else here is because it's already stretched. Everything here is already stretched, so we don't have to really play with these settings. You can if you want. And I wish I could make the glob here look a little bit better in Siril. I've had trouble with this in PixInsight as well, but one thing we can try is go to Advanced, do an inverse generalized hyperbolic transform, and then see if we can kind of tease out the stars there. It doesn't look like it works. But anyways, we can play with the inverse though to make the stars be a little bit less in the way. There's a lot of clipping here. This is from the Verilux hypermetric stretch and the star removal parts here, so it's totally fine. Okay, I think this is okay. I don't think we have to really do anything else. We could move the symmetry point or the, sorry, if I go down here, move the black point on the nebulosity part. I don't want to do too much. Okay, I think this is okay. I'm gonna click on apply, play with these settings, see how the composition works for you. And I'm pretty happy with this. Minus the globs here. I wish it looked better. I have less trouble with other dusty nebula, but this is just something to keep in mind. You can try removing the stars ahead of time. One thing that Siril is still missing is masking, so I wish I could mask this entire region so it doesn't brighten up this much. And then now we can save this as let's see, Siril dark doodad. Perfect. Finally, here I can mark this as complete, and we have worked through all of our images, all of our steps here. And again, like I said, I'll share this. And the one final thing you can do here is if for some reason your thing looks a little bit too green, like mine actually does look like it has a green tint here, we can kind of see it if we go to stretch and do histogram transformation. We kind of see that the green is kind of to the right of the red and blue, so it stretches a little bit. So what we can do is we can do image processing. We can do remove green noise, keep it on average neutral, and click on apply. There you go. It kind of just removes some of the green as a last step. And then if we open up the histogram transformation again and we look at the green, you can see that it is much more aligned here, and it looks a lot better, at least in my opinion. It does maybe lose some of the color, so up to you whether or not you want to do it. And you can keep playing with this. I'll save this, and again, you can keep playing with this and try and tease out more of the dust here. So I'm looking forward to seeing what others can do. Hopefully this was a good framework in helping you move forward with processing dark nebulae minus a really stubborn globular cluster that's surrounded by dark nebulae. I hope that was helpful, and I'm planning on making more data available from remote observatories whenever I can. And as some of you know, I am sending one of my rigs down to Death Valley Observatory soon, so I'll have some crispy data from the Northern Hemisphere as well. I'll provide as much data as possible to paid supporters as I can, and I'll also eventually make a lot of those available for free to everyone to use and follow along as well. And with that said, a huge thanks to all of my patrons on Patreon, supporters on Buy Me a Coffee, and here on YouTube. You've given me the confidence to have multiple rigs around the world and to do these videos, so huge thank you. And as always, thank you for watching, and until next time, clear skies.